Hello, I'm Timmy, captain of 4634 FROGbots. Last year for Frog Nation, we had two teams, Team 4634 and Team 17160. 17160 went against the meta to build a scissor lift robot. A lot of teams tried this idea and did not do it successfully. So we would like to show our ideas for the scissor lift and how you could use this in the future for future challenges.
One of the challenges in building a scissor lift is powering it. For this scissor lift, we decided to power it using two lead screws, here and here, on either side of the robot. We made these lead screws at first horizontal, but we ran into some problems with binding on this scissor lift, and we realized that because of vectors and stuff like that, when your scissor lift is vertical and you push up on the scissor lift instead of trying to pull it sideways, it's more efficient and allows the scissor lift to raise much more smoothly. Now we also realized another issue, which would be the unevenness in the scissor lift, which was due to if you didn't connect the two lead screws so they weren't in sync, if you will, over time they would become uneven and you'd have an uneven scissor lift, which is not good. The answer to this involved chaining the two lead screws together, as you can see here. So here's one motor, it's a Never Rest 13.7, and another Never Rest 13.7 right here, these two big sprockets. Here, these two slightly smaller sprockets are hooked up to our lead screws, and you can see the whole thing, it's in sync as one system. So the lead screws will always be in the exact same rhythm. It makes it super smooth. These two idler sprockets right here are what give the chain a little bit of a better grip on our motor sprockets, and this right here is a tensioner to keep the chain from falling off. An important thing we discovered in the making of this scissor lift is the necessity of attaching it to the robot in a specific way. So let me remove this panel very briefly. So basically, the ends of lower ends of the scissor lift, as seen here and here, need to move. When the scissor lift goes up and down, these two ends move in and out, okay? So they both move in when you're going up, they both move out when you're going down. Now, we decided that some sort of rail and wheel mechanism would be essential for this task. So we went with the X-Rail and Mini V-Wheel kit from Actobotics. It works quite well. We secured the wheels on all four sides, 1, 2, 3, 4, and had a plate right here down at the bottom to secure it. We then attached that whole assembly to a U-bracket right here, axle, bearings, give it strength yet smoothness in operation, and used a D-hub to attach to our beams. Speaking of the beams, an important thing to note with the beams is you have to make them triple thick, if you will, because with the scissor lift, even though we've gone with the optimal design, vertical lead screw, rubber band tensioning, there is still a lot of stress. So with the triple beams, we were able to manage to eliminate or at least minimize the bendage of the beams. If you don't do this, you will have the beams bend sometimes. In our early models, this did happen. Now for some of the more finite details on building a scissor lift. So the first thing we would like to cover is the importance of rubber band tensioning. Now, in the beginning of the scissor lift, when it's first starting and the beams are kind of like this, the motor has a lot of trouble pulling those beams up just because of vectors and forces and stuff like that. Basically, the short story is these rubber bands help give it the quick kickstart it needs to get into the air. Another thing that we would like to stress is a very, very lightweight top. So we used a rev beam here and custom 3D print slides. We used rev slides over X-rails at the top because they're especially light, and then we used 3D print sliders because they were smoother and easy to attach to the beams. We used Lexan with some aluminum supporting right here to attach the two parts, and we used a single Misumi slide instead of 2, also for the sake of being lightweight. Now, one thing you may notice on this scissor lift is the amazing green wire wrapper. It actually serves more than just representing the team color. It also protects our wires from the scissor lift. So, it's much more visible on this side. But as you can see, the scissor lift very much will scissor things, including wires. That can stop all of your components up here from actually working. So if you coat your wires and make in wire wrap and make everything nice and clean and tidy, it shouldn't be a problem, but it is something to watch out for. The last thing to cover would be the beams. Now, scissor lifts have a lot of stress going on inside them, so you need a lot of thick beams. What we did here was 2 beams here and then a beam sandwiched in a U mini channel bar. We erased this during the top to only double and single beams just for the sake of lightweightness, and it wasn't as necessary at the top, but at the bottom it was an essential thing to do. And here's the scissor lift in action.